presenter tonight is coming to you from the Bay Area around San Francisco remotely, and he happens to be my son. And so he's a pretty sharp cookie, and so I hope you enjoy the presentation. And I don't know what else to say. Scott, go ahead, take it away.
That's perfect. Thanks for the great intro, Dad. That's the second time today I've been compared to a baked good, so I must be doing something right. So, hi everybody. I'm Scott, and let's do our tour through the solar system. I'm not sure if any of you have caught one of the previous presentations I've done before, but basically for the last 5 years now, I've been crawling my way through the solar system. And today we're going to conclude. So, very exciting time. So, this is just a quick look at our solar system. So, in previous presentations, we covered the inner solar systems, the terrestrial world, so Mercury, Venus, Earth, Mars, then Jupiter, and then another one on Saturn. And today we're going to work our way from Uranus through Neptune and all the way to Pluto. And we'll answer that nagging question, is Pluto a planet? Spoiler alert, no it isn't. So, let's first talk a little bit about the scale of the solar system. So, on the previous page here, all of the planets look like they're in a nice, even space distance, and they're all kind of friends, right? Well, not quite. So, this chart actually shows you what the distances actually look like. So, you can see the tiny blue dot all the way to the left, that's representing Earth. And then you can see the even tinier gray dot all the way to the right, that's Pluto. So Pluto is, on average, more than 40 times further from the sun than we are. Which means that if light from the sun takes 8 minutes to reach us, it takes 5.5 hours to reach Pluto. So that's really, really, really far. And as a result, we haven't sent very many spacecraft out in our solar system to try to explore these worlds. So today we're mostly going to be talking about the ice giants. So those are Uranus and Neptune. So that doesn't mean that they're balls of ice in the like pack a snowball and freeze it kind of way. That means that they're made of elements heavier than hydrogen and helium. So Jupiter and Saturn are basically just giant balls of hydrogen with some extra helium thrown in for good measure. The ice giants, Uranus and Neptune, on the other hand, are not just hydrogen and helium, but also methane, that gives them the color, ammonia, and different kinds of ice. So water ice, ammonia ice. And I mentioned that these are not solid objects. They're not. They're still giant and they have a clear surface. The ices are under so much pressure in these atmospheres that they become what we call a supercritical fluid. So they have properties of gases, but also some properties of solids and liquids. You wouldn't want to go swimming, mostly because you would die. So for a long time, this was the best view you could possibly get of Neptune and of Urus, and to say nothing of Pluto. So basically, these are pictures taken from an 8-inch telescope. Some of you might have one like this at home. There's probably one outside the observatory right now. And as you can see, you don't really see a whole lot. These are very, very distant objects. But with a good scope and clear skies, you can actually pick out a couple of the larger moons. And we'll talk more about those later. Having a giant telescope like Hubble certainly helps things. So this is the kind of view that Hubble can get of Uranus on the left and Neptune on the right. But fortunately, we've also managed to build a couple of robotic emissaries to go out there to the far reaches of the solar system and see things up close and personal. So on the left, you've got Voyager 2. It was launched in 1977. It reached Uranus in 1986, the year I was born, he said, feeling old. And it reached Neptune in 1989. Then on the right, you've got New Horizons. This was in the news pretty recently. It was launched in 2006, and it arrived at Pluto 9 years later in 2015. So both of these probes are alive and well. Voyager 2 is almost 11 billion miles from home, which is crazy. And New Horizons is almost 4 billion miles from home. So they're both moving very quickly. So let's start our tour. Let's talk a little bit about Uranus. Some of you may have pronounced it Uranus. I think they're both technically okay pronunciations. I prefer Uranus just because it causes fewer giggles. But yeah, so it's actually the only planet in the solar system named for a Greek deity instead of a Roman one. So it's Uranus, the deity of the sky. Like I said, it's an ice giant. Lots of hydrogen, helium, methane, ammonia, water. It's got a wacky axial tilt. That means, well, I'll get into what that means in a minute. It's about 15 times heavier than Earth. It's 50,000 kilometers across, and one of its years lasts 84 Earth years. So it's really far out there, and yeah, it takes its time, that's for sure. It also has 27 known moons, and we'll get to know a few of those a little bit better in a minute. So what's kind of cool about all the planets we're talking about today is that they were all discovered pretty recently. So Uranus was discovered by William Herschel in 1781, making it the first modern discovery of the planet. All the others were known to the ancients, with the exception of the outermost one. So he found it. At first, he thought it was maybe a star or a comet, but after further observations, he figured it out. So if you're going to remember one thing about Uranus, probably the best thing to remember is that Uranus is the one that's tipped on its side. So it's got a 98-degree tilt. Earth's, on the other hand, is 20-something degrees. So that's what gives us our seasons. That's why days are longer in the summer than they are in the winter. So on Uranus, because it's tipped basically exactly on its side, every summer and every winter lasts a very, very long time. And as a result, the winters are 40-something years ago. Yeah, so Antarctica on steroids, really. So how did it get that? It's thought that a large object, maybe 2 or 3 Earth masses, just nailed Uranus, hit it very hard, and actually shoved it over on its side. So that would have been pretty cool to see. Unfortunately, we don't have any pictures. But some other things happened when that impact occurred, we think. So there are a couple of weird things about Uranus besides it being on its side. One is that its magnetic field is very strange. It doesn't come from the center of Uranus, and it doesn't match up with its poles either. And Uranus is also the coldest planet in the solar system, despite getting more solar energy than Pluto. It's got what we very little flux. And it's believed that an impact long ago could have caused Uranus to lose a lot of its internal. So if we go back a couple of slides real quick to refresh our memory, this image was taken by Voyager 2 in 1956. As you can see, Uranus basically looks like a paint swatch. It's just a plain robin's egg blue ball. Kind of boring. What is it, though? So Hubble images suggest there's a lot more going on to Uranus because of its seasons. So when Voyager visited in '86, that was right as the summer solstice was happening on Uranus. So weather was very calm. That end Uranus had been pushing the sun for time. years passed since then, obviously. And since then, we're seeing a whole different side that was completely dark when Voyager visited. So in pictures, you can see some bright spots on Uranus from Hubble. Those are storm cells and aurora you couldn't see before. So it's not Uranus is boring, that it's kind of shy. It's just now starting to show itself, which is why I'm a big fan of the idea of sending a probe out there, kind of like we have with Saturn. So let's talk about some of Uranus's moons. So you've got Titania on the left, Oberon, Umbriel, Ariel, Miranda, and 22 other smaller ones. These are rocky, icy moons. Most of them are pretty big. Titania is the 8th biggest moon in the solar system. And they've got some pretty cool features. So Miranda looks like a Frankenstein moon. It's stitched together in all kinds of weird ways. One of these, I believe it's Ariel, has the highest cliff in the solar system. It's like a 6-mile high cliff. You would not want to fall off of that. And yeah, it's an interesting cast of characters. So as we leave Uranus, let's take a look at this last picture that Voyager snapped of Uranus. It's kind of the crescent as it's whipped by Uranus very quickly. And let's make our way to Neptune. So named after the Roman deity of the ocean, I'm sure you can understand why Neptune is just this really cool royal blue color. So it's, in a lot of ways, very similar to Uranus. So it's got almost the exact same diameter, just a hair smaller, and it's a couple of Earth masses bigger than Uranus, or heavier, I should say. But it's a lot further out there. So it's 10 astronomical units further. So it's 50% further than Uranus is from the sun. And it takes 165 years to go around the sun once. So it's slow, it's taking its time. And it's only got 14 known moons, which is actually kind of a tragic story. We'll get into it. So let's talk about how Neptune was found. So Neptune actually was the first and so far only planet to be predicted mathematically before we actually found it. So it was discovered in 1846 using calculations by a number of different people, including Urbain Le Verrier, a Frenchman who usually gets credit, making it kind of a joint British-French-German discovery. So they predicted it based on some weird behavior that Uranus has. And I know what you're thinking. Oh, Uranus being weird? What else is new? But what was happening was at certain points in its orbit, Uranus was speeding up. And at other points in its orbit, Uranus was slowing down, which could only be explained, Le Verrier said, if there was another planet tugging at it. And lo and behold, when they actually started looking around midnight on the 23rd of September in 1846, they found it within an hour, within 1 degree of where Le Verrier said it would be. So mathematics, they really work. And recently, actually, we've uncovered documentation that suggests that Galileo, of Jupiter fame, initially observed Neptune, but maybe didn't realize it was a planet. You know, a couple of centuries before it was actually discovered. So that Galileo, he was a talented man. But let's talk a little bit about Neptune. So we've got a couple of pictures here. The picture on the left is what we call Neptune's Great Dark Spot. It's an anticyclonic storm, which has often been compared to Jupiter's Great Red Spot. It's a little bit of a different beast. Instead of being a large storm cell that is kind of big and bulky, we actually think it's a hole in Neptune's cloud deck. So you're actually just seeing deeper into Neptune there, is what we think. And it's one of many storms. You can see them pretty well on the right. All the different bands and clouds in that contrast enhanced image. That's why it's black and white. So Neptune is actually a very curious place. So Uranus, it's very cold, so it only radiates a little more energy as it receives from the sun, whereas Neptune is actually very hot, considering how far it is out there. So it radiates 2.5 times as much energy as it receives from the sun, despite being the furthest planet. So it's got a lot of internal energy. So much, in fact, it has the fastest wind seen in the solar system. These have been clocked at more than 2,200 kph. That's 1,300 miles per hour. So the next time there's a thunderstorm, we've got it pretty easy, all things considered. So next, let's talk a little bit about Neptune's moons, shall we? So my favorite, they're all important. My favorite of these is Triton. That's one of Neptune's 14 known moons. It's the largest of them, and it's actually a pretty wacky place itself. So it actually orbits backwards. So it has what we call a retrograde orbit, meaning it orbits in the opposite direction of all the other moons around Neptune. So it's widely thought that Triton was actually captured from the Kuiper Belt. So that means Neptune's gravity grabbed it and kept it around Neptune. Some additional facts that support this include the idea that Triton has pretty much the same composition as Pluto, which we'll be talking about a bit later. So Triton is a really exciting place because it's one of the few moons in the solar system known to be geologically active. So Jupiter has a couple of geologically active moons, and so does Saturn, but now it looks like Neptune does as well. So in these pictures, you can see some dark smudges on the southernmost side of the moon. Those are actually cryovolcanoes. So those are volcanoes that spew basically water ice or other volatile fluids instead of lava. So also on the right, you see, it's probably hard to make out, but you can actually see clouds above the surface of Triton there. So there is at least a transient atmosphere. So the sad thing about Triton, and about all of the other moons around Neptune, or most of them anyway, is that they are all doomed. So when Neptune captured Triton, whatever moons it might have had were just thrown into total chaos. They must have been colliding with each other, getting thrown away from Neptune, getting thrown into Neptune, smacking each other again. As a result, Neptune has fewer moons than other giant planets we've seen. And the innermost moons are just scattered remnants. They're irregular, not even potato shaped. They're like strange polyhedral fragments. All of them are too close to Neptune to maintain stable orbit. So do not invest in real estate on any moon of Neptune, especially not Naiad, because they're all on a one-way ticket into Neptune. So over the course of the next couple of billion years, Triton and all of the moons closer to Neptune are probably going to get torn apart by Neptune's gravity. So Neptune is very likely in the future going to have rings that will make even Saturn quite jealous. So let's leave Neptune behind. This is the final shot that Voyager captured of Neptune. You can also see Triton there in the southernmost region, but just a beautiful shot. And let's talk about Pluto. Named for the Roman god of the underworld, known as Hades in Greek. It's a dwarf planet made of largely ice and rock. It's got a wacky axial tilt because it's so small. and it's really, really small. It's 0.002 Earth masses. It's only a little over 2,000 kilometers across. Takes almost 250 years to go around the sun once. So that's a very, very long time. And it has 5 known moons, and we'll get into that. So Pluto was discovered in 1930 by an American named Clyde Tombaugh. And as you can see in the 30s and for a long time after, that dot was all we knew of Pluto. It was just a tiny, very difficult to see blob. When we invented Hubble, things got a little bit better. We got a slightly larger pixelated blob. But it wasn't until New Horizons reached Pluto in 2015 that we got our first really, really good look at Pluto, and we started to understand what dwarf planets are all about. So, dwarf planet, what does that mean? Why do we say Pluto's a dwarf? Well, the obvious answer is that it's small. Pluto is a very tiny place. You can see it next to Earth and the Moon. It's smaller than our Moon. But it wasn't until we discovered Eris, you can see that to the left of Pluto here, that we kind of realized that we had to change something. So Pluto is very small. It's out in what we call the Kuiper Belt. And we think there are dozens, maybe even hundreds of little objects like Pluto out there. So the thinking is, if we have to include Pluto as a planet, then we're going to need to include Eris and Ceres and Sedna and Makemake and so on. So rather than have a solar system of maybe 90 planets, the idea was to demote Pluto into dwarf planet status and still keep 8 major planets. Now, that doesn't mean that Pluto is any less important. It's still a very important, very exciting place, but it's just not classified the same way it is. So, it's distant, but a very dramatic place, lots of character. So, here we see a closer view of the Heartshape feature you saw a couple pages back. See that kind of heart shape? Well, that's actually a glacier of frozen nitrogen the size of Texas. So it's a huge feature, and it's a very smooth feature. So Pluto, not only does it have this vast glacier, it's got blue skies, spinning moon, mountains as high as the Rockies. It actually snows on Pluto, although the snow is red. You can kind of see some of that in the image here. And these are all details before we didn't know before New Horizons reached it. So just looking at this image, you can see that it's a pretty smooth surface. That means that it's young, that there are active geological and meteorological processes going on, which erases craters over time. That's how we know it's a young surface. But there are also other pretty exciting features. So one of them, Wright-Mond, W-R-I-G-H-T, named after the Wright brothers, which you can see here in the enhanced image on the right, is a massive cryovolcano, 90 miles across and almost 3 miles high. So if this is a cryovolcano, it's the largest we know of in the solar system. And it would be pretty cool to watch that around. So this is a great photo that New Horizons snapped as it was passing Pluto. Kind of a look at the Pluto sunset. So Pluto does have a thin atmosphere. It's mostly made of nitrogen and methane. And this image here really shows all of the different layers in the atmosphere, and that's caused by different thermal layers. You can kind of see that almost that ring effect. So Pluto's atmosphere, funny enough, due to the high concentrations of methane, is actually considerably warmer than the surface of Pluto. It's still really, really, really cold, colder than anywhere on Earth gets. And here's a colorized version of that same photo. It's not entirely accurate. There's some artistic liberties taken, but I think it's just a beautiful picture. And here you can actually see those mountains in really clear relief. So let's say hello to Pluto's little friends. So it's got 5 known moons. They're all named after different guardians of the underworld in mythology. So you've got the largest, Charon, I believe, let's see, not Bridgekeeper. He is the Toll Keeper. I don't know. I'll have to brush up on my Greek mythology. But the point is, that's the largest and most important of the moons. And we also have Styx, Kerberos, Nyx, and Hydra, which are all kind of regular potato-like moons. But Charon is actually a very interesting place all in its own right. So if you look at this picture, it's a pretty special picture because this picture is actually to scale. So if you were to be in a spaceship a little ways from Pluto and you look out the window, this is perhaps more or less what you would see. So Charon and Pluto are similar sizes, very similar. So obviously Pluto is a bit bigger, but Charon is a large fraction of Pluto's size, and they're very close. So they're so close that Pluto and Charon are what we call tidally locked. So the same side of Pluto always faces the same side of Charon, and they're also a double planetoid, meaning they orbit each other instead of one of them orbiting the other. And I just can't get over how cool this picture is. Because again, this is what you would see if you were to look out a window. You'll notice that Charon is a lot darker. That's because it is, in fact, a lot darker than Pluto. And last but not least, let's take a look at Pluto's atmosphere. So New Horizons was almost directly behind Pluto when it snapped this photo. And you can see the atmosphere, the blue haze around Pluto caused by the methane and the nitrogen. Just a stellar photo. So that concludes our whirlwind tour through the outer solar system.